So this here is a universal plotting sheet. This is what the tool we're going to be mostly using to actually get your fixes in CellNav. So as I went over in the last video about how you finally find a line of position through like celestial observations, when you get that, you could theoretically just put that down on any chart. If you know your general area, you could plot it down right there. But the purpose of CellNav is to use it in the middle of the ocean where you don't have another nav aid that you could use more easily. In which case, A, you don't necessarily know where you are, and B, a chart might not exist, or if it does exist, it's a general sailing chart that's like an entire ocean basin, which isn't of much use to you. This is something that you could use at a much smaller or much larger scale, so more zoomed in, so you could actually get an accurate fix while you're out in the middle of nowhere in a spot where there won't be a chart at a scale that's usable. And the reason why these are so useful is they can be for any location anywhere in the world. You can see this scale down here. This is what you use to calibrate it. There are only horizontal lines here, meaning we only have parallels of latitude because parallels of latitude don't change. But the width separating your meridians, it changes by latitude. You can use this scale to adjust how far apart you want to manually place those meridians, meaning that this could be accurate at any latitude anywhere on Earth, and you could just set them to certain values. If you wanted this central meridian here to be like 0 or 90 degrees east, you could make it 90 degrees east. If you want it to be 45 degrees west, you could do that. This can work for anywhere and therefore be used as often as you possibly need for celestial fixes. Now this compass rose in the center here, you can use that to get bearings. It's mainly used, however, for calibrating the page as well. If you wanted to, you could measure an angle off of it, but if you're already going to be working with your triangle, so you could just use your triangle for that anyway. Ultimately, what you're going to be doing, if you remember going back in the previous video, let's see where it is. Yeah, here. If you remember this diagram here in this explanation, after you do all the calculations based off of this quadrilateral here, what it's finally going to give you in the end is your assumed position and the difference between your height based off of your observation and the height based off of your computations, which will then be transferred over to be a distance away from your assumed position in the direction of the azimuth, and then from there you'll get your line of position. So that's the things that you would be plotting on this plotting sheet. You would find your assumed position wherever it may be. Let's just say it's right there. You would find your azimuth, say it's somewhere like that, and then once you measured out the distance that's equal to the difference between the two heights, you would then set that as the location. It's called the intercept of your intercept, and then draw your line of position like that. Once you did that 3 times, you would be able to find a reliable fix. Now, when you're using this, just as one minor note, when you plot on it, you can see these come in pads of about 50 sheets, each one being double-sided, so you got 100 opportunities to plot on here. What you don't want to do is you don't want to just work, let me back up. You don't want to just work on the pad as a whole. All of this paper stacked together, it's almost like spongy, meaning when you're plotting on this, you could kind of warp the shape of the surface and it might throw off your accuracy. But you also don't want to plot on just one single sheet because when you do that, I wish I had my dividers with me. Your dividers would just punch straight through the sheet, potentially into the table, or it might tear the paper, cause you to kind of spin around, like cause the paper to spin around your divider, things like that, because there isn't much traction. So what I was taught is you should usually have like 2 or 3 sheets underneath. Hold them all off. Then you can move the pad aside and just plot on this. So this is 3 total sheets. You could plot on the top one. When you're done using this one, you would then tear it off and flip it over. And then once you've used both sides and this is useless to you, you could just turn it to the bottom and then use it at on the bottom side. This provides like an optimal amount of both kind of penetrating through the paper itself and staying together. The sheets will kind of hold themselves in place, but it won't get so spongy like the entire pad will. So this is just a really quick overview of like the absolute basics of using this plotting sheet.